Section 2.6 is going to be about the combinations of functions. To start this discussion, let's discuss what the domain of a function is. The domain are all values of x for which a function is defined. Another way of thinking about it is all values of x that doesn't break any rules with the function. For example, we'll exclude from the domain all the x numbers that cause division by 0 or the square root of a negative number. By and large, those are going to be kind of the two things we look out for now to address what's in the domain and what's not in the domain. So we're going to look at some function examples to determine the domain of each of these functions. On this one, f of x equals x squared minus 7x. This is what we refer to as a polynomial function, and this one has nothing really to worry about as far as the domain is concerned. It has no division by a variable like x, nor does it have any square roots. And as a result, there's really two of the main things that would cause issues are not there. So the domain of a function like this that just involves like powers like 2 and multiplication and subtraction, stuff like that, would be all real numbers. And we're going to write that in interval notation as negative infinity, comma, positive infinity. So in those cases, they're a pretty straightforward type of function when that happens. On the other hand, a function like g of x has a lot more going on. 5x over x squared minus 49 minus 5x over x squared plus 49. So in this case, we do have to check for the division by 0. So how do we do that? Well, we take each of these denominators and set them each equal to 0. Okay, for the first one, I'm going to add over the 49, like so. So I have x squared equals 49. And then we're going to take the square root of x squared and the 49. But in order to solve, we have to put the plus or minus in front of the number. So x would be equal to plus or minus, and the square root of 49 is 7. So those are two numbers that are not in the domain because they cause division by 0. On the other hand, with this other equation, I would subtract the 49 over and have x squared equals negative 49. But if I try to take the square root like I did over on the other one, now that's the square root of a negative number. That's not a real number, so there's no real solution to this one. So there's no additional numbers to have to consider for solving this particular denominator set equal to 0. So we'll only have to worry about these two numbers here. As far as the domain then is concerned, every number except for negative 7 and positive 7 will be part of the domain. I'm going to mark them off here on the number line. I'm going to put an open circle at those two numbers, and then I'm going to show how the domain will be all the other numbers except for those two. So for everything from negative infinity all the way up to negative 7, also from negative 7 to 7 in parentheses, and then from 7 on to infinity. When we list out the intervals together to state the domain, we put a little U symbol, which is the union. And so all together, these make up the domain intervals of the function. Okay, now on this one, h of x equals square root 9x minus 27. In this case, we have to check for where the square root has a negative number inside of it, since any square root of a negative number is no longer a real number, and we're only working with real numbers for the domain. So the way we do the domain here is to solve for what's on the inside of the square root, and we solve what's inside the square root for greater than or equal to 0. So we're going to take just the 9x minus 27 greater than or equal to 0. Solve this for x. And divide by the 9. And it'll say x is greater than or equal to 3. And that specifies the domain for this function. The domain will be all the numbers from 3, including the number 3, all the way off toward infinity. So we'll have a bracket at 3 since we're including that number, and everything greater than that. Or we'll write that as bracket 3, comma, infinity. Now let's look at this function, which is kind of a combination. J of x is equal to 3x plus 2 all over the square root of 14 minus 2x. So like in the last one, we're going to solve what's on the inside of the square root for greater than or equal to 0. But we can also make note the denominator can't be 0. As a result, we can simplify our process here. We're going to drop the equals part of the greater than or equal to. So what that means is we're going to just solve for 14 minus 2x strictly greater than 0. That way we're dropping the part that would cause division by 0 in the denominator. That'll be enough to figure out what the domain is on this one. So I'll solve, subtract the 14 over, negative 2x greater than negative 14. We'll divide by negative 2 here. When we divide by a negative, that's going to flip the sign of the inequality, and then it'll turn into less than. X less than positive 7. So the domain here would be made up of all the numbers less than but not including the number 7. So with an interval notation, we use a parenthesis there, and it should highlight everything on that side. We'll say negative infinity comma 7 close parenthesis is the domain. We can actually combine functions using addition, subtraction, multiplication, or division, and this is referred to here as the algebra of functions. The first one says f plus g of x is equal to f of x plus g of x. That's the sum. The difference, f minus g of x, is f of x minus g of x. The product, fg of x, is f of x times g of x. And the quotient, f over g of x, is equal to f of x over g of x, as long as g of x is not equal to 0. We consider that the domain of a combined functions is the set of all real numbers which are common in the domains of both functions at the same time. So we're going to look at a few examples of this to determine the combined function and the domain. The first one, we're going to find f plus g of x. And that means we take the f of x function plus the g of x function. So we start with f of x, which is 2x minus 1, plus the g of x, which is x squared plus x minus 2. So putting those together, we'll combine their like terms. We'll have an x squared. We have a 2x and an x, which go together to make 3x, a negative 1 and a negative 2, which go together to make a negative 3. For f minus g of x, what we're going to do is take the f of x function, which is 2x minus 1, and subtract away the g of x, which is x squared plus x minus 2. Notice how I kept it in parentheses. That's because the negative is going to distribute everything I'm subtracting from g of x. So it would look something like 2x minus 1 minus x squared minus x plus 2. Combining the like terms together here, we'll have a negative x squared plus x and plus 1. Now the next one, fg of x, means to multiply the two together. F of x times g of x. Okay, that's a little bit weird looking because we start off with a 2x minus 1, but we're multiplying that by x squared plus x minus 2. And so in order to multiply these together, I'm going to distribute one of the things over the 2x. That'll distribute to each of the terms. So start off here, we're going to have a 2x to the third plus 2x squared minus 4x. Then I also have to distribute over the negative 1 to everything. And if we do that, it'll turn into negative x squared, negative x, and positive 2. So combining the like terms, we have a 2x to the third. We have a 2x squared and a minus x squared, which would go together to just be x squared. Negative 4x and negative x would go together to negative 5x, and then plus 2 at the end. Now for f over g, that means we take the f of x divided by the g of x function. And in this case, it's just going to be 2x minus 1 on top for f of x, all over x squared plus x minus 2. And more or less, that's what the two would go together in this instance. Now, it did also mention the domain. In this case, if we wanted to know what the domain is of this function, we would take the denominator and set it equal to 0. In the case of this x squared plus x minus 2, we can actually factor what we have here if we want to solve it. And if I factor this one, it would factor to be x plus 2 and x minus 1. And when we're trying to solve with factors, we would take each factor and set it equal to 0. And if we solve each of these things set equal to 0, we would get two numbers. One would be negative 2, and on this one I would plus 1 over to get x equals positive 1. So the domain are all the numbers except for those two. So highlighting it on the number line here so we can see. And in interval notation, it would go negative infinity to negative 2, union with negative 2 to 1, union with 1 to infinity. Now, I didn't mention the domain of all the others here, but they were not very complicated as compared to the last one with the numerator-denominator. Just to mention, these are all cases where the domains are all real numbers. So the first one had domain of all real numbers here for fg of x. Both f plus g and f minus g are, again, situations that don't have division or any of those things. So they are going to have all real numbers for each of their domains. I'm going to take a look at this one here, where we have an f of x equals to square root of x plus 3, and g of x is equal to x plus 10. We're going to start off by finding f plus g of x. And that's actually not a whole lot there to combine, but we do start with this is equal to f of x plus the g of x, and that would equal to the f of x function, x plus 3, plus the g of x function, x plus 10. There's really no terms we can combine there, so that's all it would do. We would see something very similar for f minus g, which would just be subtraction instead. It would look like the square root of x plus 3 minus the g of x, x plus 10. We could go ahead and distribute the negative and rewrite it as the square root of x plus 3 minus x minus 10. G of x would be, when we multiply these together, f of x times g of x. With the two functions we have here, that would look like the square root x plus 3 times the x plus 2. Now in this case, since all that stuff is in the square root with x plus 3, that's really all I can do at this point. They don't really distribute or FOIL out in any meaningful way. Now for the last one, let's do f over g of x. That would look like the square root x plus 3 all over x plus 2. And that's all that's going on here. That's what that would look like when put together.